Oh, we're going to talk about exponents. Now, we're going to totally change the game here. Everything that we've been talking about for the first 4 units have been about linear equations. So we're going to introduce another function, another equation next lesson. But first, we're going to talk about what it's going to be made of, and that's going to be exponents. So today, we will know the meaning of an exponent and be able to perform operations with exponents. So let's get some terminology down. This right here is the base. And actually they do use B quite often. So B for base. And the thing that sits above the base is the exponent. Now let's remember from prior, math classes that the exponent tells us how many times to repeat the base. So we've got the Bernie sitting there for, the inauguration of Joe Biden, and it's raised to the third power. So what does that really mean? That means we have, oops, no, that's still going to be on. That means we're going to have not one, not two, but three Bernie Sanders hanging out there because it's to the third power. So it's how many times we repeat that number, that image, whatever it is. It's actually a shorthand way to write. Oh, there's one. Bernie on the Throne from the Game of Thrones. Anybody? I actually sat down and watched it last summer, I believe. So pretty good series. I'd wait until you're a little bit older to understand it. All right, so we got some basic rules that we want to make sure we follow. I'll give you a few examples. Any questions, again, type them in the chat. Use your microphone and let me know. So the multiplication rule, if we have the same base, and if that base is, the same, A and A, we can add the exponents to represent how many we have. So a quick example, let's use 2, because 2 is simple. 2 to the third power times 2 to the fourth power, all right? Now again, what does that really mean? Let's duplicate it. That's 3 2's, okay? And my x here, 4 2's. So if I have 3 2's and 4 2's, that means we have 7 2's. And so that would be an easier way to write it. Now we're not going to write it out every time. We're going to know to add the exponents when we are multiplying the base. The division rule. Let's talk about, let's say 2 to the fifth. And let's divide that by 2 to the third. Well, I'm going to make a fraction for this because I like fractions better than I do that division sign. And I'm going to put 5 2's up top. And then I'm going to match it with 3 2's in the bottom. Okay? So think about this. If we were to subtract these, 5 minus 3, I'd be left with 2. And that's exactly what I have. I cancel these out. 5 minus 3 is 2, so the division rule is to subtract when you are dividing the same base. All right? Next one, a power to a power rule. If I have something that's in parentheses that has an exponent that is raised to another exponent, I can multiply. So let me show you this. Whoa, that is funky. 2 to the third raised to the fourth. Well, that is written out as 2 to the third, 2 to the third, 2 to the third, and 2 to the third. Basically, it says that we have 4 of them. Now, I can add those. 3 plus 3 is 6, plus another 3 is 9, plus another 3 makes 12. But what's a faster way to add? We've got multiplication, right? Multiplication is repeated addition. So 3 times 4 would have known that there were 12 from the start. All right, so your rule for that is to multiply. Basically, what I'm showing you here, folks, is the expanded form, it all written out, and then why the rule works. But we will not have to write it out every single time. Now, the last thing is, if this something is raised to an exponent, make sure you give that exponent to everything that's in the parentheses. So, for example, putting more of a perspective here, let's say we had 2x to the third power, and we're going to do that 4 times, okay? So that means that the 2 will be 2 to the fourth, and the x will be 3, remember, times 4, because it's exponent to exponent, so that means we multiply. Now, be careful here. 2 to the fourth is 2 times 2 times 2 times 2. That's 4 2's, right? So that actually is 16. Use your calculator if you need to. And 3 times 4 means that that's 12. But basically, remember that exponent has to go to the terms in the parentheses, all terms. Now, 0 power. Anything to the 0 power is worth 1, so remember that. And a negative exponent, think about it as an indication that the base is in the wrong part of the fraction. All right, so if it's it's a to the negative x, we rewrite that as 1 over a to the x. We go from numerator, all right, where it currently is, into the denominator. So you switch it around. So we've got example A with x to the third, x to the fourth, and x. Basically, how many x's is that? Well, it's all the same. So a better way to write this is with 1x, and 3 plus 4 plus 1 would be 8. So x to the 8th power. Now in this next one, we've got numbers and variables. All that means is that we want to multiply the numbers like normal and then combine those exponents accordingly to the rules. Well, I could take these all apart. We talked about this in the beginning of the year. This is the commutative property. So the commutative property allows us to multiply the terms that are alike. 7 times 5 is 35. And then multiply the bases here, the y's, which means we really have 8. So 35y to the 8th. And just rewriting it helps you see what goes together. We'll keep it going. With this next one, a little bit more going on. Just, again, rearrange it using the commutative property. So it's -3 times the 4. And then let's put the x's together. We go alphabetical order with this. Then the y's. And then finish it up with a z, which I put a little line through my z. Okay? So I took the same information and I rewrote it using the commutative property. So -12, x to the third, because we're adding 2 plus 1. Let's add the 3 and the 5, make 8. The z has no friends here, but it's still a part of our gang. And there you have it. -12, x to the third, y to the 8th, z. And again, a lot of this can be done in your head, just kind of going through a small step to show you the right process. Next up, we've got parentheses. Now, the only thing here that's different is it's in parentheses, which still shows multiplication. Now I can still remove it from those parentheses, totally fine to do. So 5 times -3 is going to go together, and that's going to make -15. I'm a little out of room here, so I'm going to break up the letters down here. I have a to the third and an a, and I've got b to the 6th. Now only like terms, so this is going to be a to the 4th, b to the 6th. I cannot add the 4 and the 6 because the a is different than the b. Put it all together as -15, the two numbers that were multiplied. Combination of the a's make 4, and then b to the 6th. If we have n to the 7th, 7 n's, and we want to show that 3 times, we can write it as n to the 7th, n to the 7th, n to the 7th, and we can add those 7's. But hey, think of it this way. Think of it as just 7 3 times, right? 1, 2, 3 times, which really is n to the 21st. So we will multiply those. Let's continue on with the same ones over here. This time we have a 2n to the third. So that 2 also gets this exponent. So 2 to the third, and then n to the 3 times 2. I'm just going to take the shortcut and use our rules. 2 to the third is not 2 times 6. It is 2 times 2 times 2, which is 8. And then n to the third, 3 times is really 9. So just make sure you're multiplying those exponents. Next up, we have a number inside the parentheses and numbers outside of the parentheses, so let's be careful here. The 3x is unaffected by this exponent of a 2, but the 4 is to the 2nd power, and x to the 3rd, yes, we have that 2 times. So why don't we go ahead and rewrite this using the commutative property, not distributive, commuting, when we put like things near each other, okay? So 3, 4x squared, then the x to the, how about just call it 6, right? Just go ahead and multiply that, x to the 6. Whenever you see a variable with no exponent, hey, throw in the 1 there. We've got 4 to the 2nd power. That's really 4 times 4, 16. 16 3 times. How about 48? 1x and 6x make 7 x's. Okay? So these ones will go pretty quickly because anything to the 0 power we saw is 1, and negative exponents just mean, hey, we're in the wrong spot. So y to the 0 power, you're just 1, all right? And then this one, be careful because we do see x to the 0, but not 7. So this is 7 times, well, x to the 0 is 1, but the 7 times 1 does keep it 7. So just be careful with that rule where sometimes you think everything is always 1 whenever you see a 0. But in this case, watch this. We're going to take that 0, we're going to pass it out. So if the 7 gets a 0, and the x gets a 0, so yes, that is 1 times 1. So that case is equal to 1. It's the difference between being in the parentheses and not being in the parentheses for those two. Now with this next one, we have a negative 3. Again, that does not make this term negative. It just says, hey, it's in the top. It's in the numerator of the fraction. It shouldn't be there. It should be in the denominator. So you just flip it around, put x to the third in the bottom, and make that 3 a positive. Keep it as simple as that, no worries. This next one, again, is a term that's in the numerator. Now a negative 5 is negative 5. That's not saying anything about the location. It's not an exponent. X to the second power, it's happy, it's positive, it's where it wants to be. But y to the negative third, we just saw it, that needs to be in the denominator. So where there was just 1 before, we take this and we relocate it and move it to the bottom and make that a positive. All right, so we're going to keep this simple and we're going to use expanded form to talk about dividing and representing this in simplest form. So remember that an exponent is just how many times we have the base. 7 is the exponent, so we're going to write out 7 5s. 1, 2, 3, 4, 5, 6, 7. Perfect. And then over that, we're going to do 3 5s. Okay? So we're going to eliminate. We're going to get rid of a 5 over 5 because 5 divided by 5 is 1, right? 5 divided by 5 is 1. So where do we have more 5s? Well, we had 7 in the top to begin with. So we have more in the top than we do in the bottom. So how many more? 4 more. So make it 5 to the 4th. We can put it over 1, but we didn't really have to. We just know that there's more 5s in the top. Leave them there. My next question, let's start with asking where are there more x's, top or bottom? Bottom, right? I'm going to write them out one more time. There are 4 here, and there are 10 of them here. Okay? Now again, 1 from the top is going to cancel with 1 from the bottom. If you can count them out, 1, 2, 3, 4, 5, 6 are left in the bottom. So I don't have anything in the top, so we put a 1 there to hold its place, and I have 6 in the bottom. Now, I kept them where they were. I kept the x's happy where they wanted to be, so they were fine there. If I had moved them to the top and done 4 minus 10, that's when it makes it a negative, when it's where it shouldn't be, which is in the top. But when it's in the bottom, it's happy, it's positive, and you don't have to worry about it. Okay? We're going to shorten this process up and just start with a fraction. And so I ask, if you have 4 x's in the top and 1 in the bottom, because we can write this as 1, where do you have more x's? You have them in the top. How many more do you have? 3. Done with the x's. We have 8 y's in the top, 10 y's in the bottom. Where do you have more y's? In the bottom. How many more? 2. Put them in the bottom, leave them there. You don't even have to worry about positive or negative because you're keeping the term happy. Let's keep it going here. And again, my rule of thumb is you can write these all out and show what I did earlier, or just think about 12 divided by 3. 12 divided by 3 is 4. Good old-fashioned 4, right? We could put it over 1, but we don't have to. I have 2 x's in the top, 3 x's in the bottom for a difference, because we are subtracting a difference of 1. Put that 1x in the bottom where there are more, and you will not have to worry about negative or positive exponents. Last one, we have 8 divided by 24. Do not switch this around. It is 8 divided by 24. 24 going into 8, which can't happen. So we can reduce it. And we can reduce it to 1/3 because 8 goes into 8 once and 8 goes into 24 3 times. Now we have 5 y's and 3 y's. Where do we have more y's? Up top. And how many more do we have? 2. And there you have it, folks. Okay?